Okay, so we will have our second example. So our second example will be at 5.4. Okay, so this is the question in 5.4. The bending moment acting on a triangular cross-section of a beam is M is equal to 3.6 kilonewton meter. Determine the maximum tensile and compressive bending stresses acting on the cross-section area. And here is its figure, okay, 5.4, okay. So it has a triangular cross-section area, okay. So unlike our first example, so I will be going to, I have already solved this one, okay. Okay. So this will be our okay, our solution, okay, for that question. Okay, so since the bending moment in the drawing, okay, here, which is 3.6 kilonewton meter, okay, is counterclockwise. So therefore, top is compression and bottom is in tension. Okay, so unlike our example number 1. Okay, so unlike the example number 1 also, our I will be equivalent to BH cube over 36 since it is triangle. Okay, for rectangle, it is BH cube over 12. Okay, so we computed the I, so this is the result. Okay, so since what is asked is the maximum tensile and compressive bending stress, so we compute the bending in tension. Okay, so your tensile or bending in tension, okay, maximum bending stress and tension will be computed as this. Okay, so since the bottom part is in tension, okay, so before I forget, since this is the triangle, relative to the lowest point of your beam, the location of your centroid is located h over 3 from the bottom, and then it will be 2h over 3 from the top, okay, from the peak of your triangle. So that is how you compute your C top and C bottom. Okay, so this is the C top and this is the C bottom. Okay, so our C bottom will be 40. Okay, so without further ado, okay, so we multiply, but then we convert the 3.6 kilonewton meter bending moment into newton meter, okay, by this multiplying factors, 1000 kilonewton per 1 kilonewton times 1000 mm per 1 meter. Okay, so MC both over I, or bottom over I. So we have computed the maximum tensile bending stress as 50 megapascals. And then for top, okay, so your maximum bending moment, maximum compressive bending stress is computed as MC top. Okay, since your compression is in the top, since it is a counterclockwise moment. Okay, so from that, MC top over I. Okay, so the difference here is the MC top is not 40. Okay, so I'm sorry, so it should be 80 here. So it should be 80. Okay, so I'm sorry, it should be 80. Okay, so your C top is 80. Okay, so to make the long story short, so our bending compressive stress will be 100 Newton per mm squared or 100 megapascals. Okay, so that is our answer. Okay, so I will recap. 5.4 is our question, and this is our solution. Yeah, okay, from top to bottom. Okay.